Okay, to continuing our series on the Renai dissection. What you're looking at here is the blower, and the blower got its air from this. This is up here along the side, came in from the top, brings fresh air in into the blower here, and then the outlet of the blower, you fit on there like this, pressurizes this lower chamber, and in that chamber, let's take this apart here, it's like a diffuser. It's like full of all these holes. So the pressurized air is squirted up through all these little holes, and then it goes through another series of holes. Now what you're looking at the front is, this is where the gas gets squirted in. Here's the burners on the top, all these little stainless steel things. That's the actual burner. And so what happens is the gas gets squirted into these, it mixes with the air that's coming in from the bottom, and then the gas air mixture comes out the top. Now here's another interesting thing, is here is the gas valve, and this is the front of this manifold assembly, I guess you could call it. Here's the rear of it. Look at all these little ports. The ports across the top are much smaller than the ports across the bottom. And I suspect it has to do with the modulation of this gas valve. It's easier to modulate at low fire and high fire, for instance. So these here are larger, and that's probably high fire mode. The low fire mode probably has them coming out of these smaller ones. And yeah, I'm not sure how they did that, or if I'm really actually correct, but at any rate, those gases squirted into these. And then of course the speed of the fan determines the size of the flame and the heat output of this thing. So when you have just a trickle of water running through here and it doesn't need a whole lot of gas to keep it warm, it probably restricts or reduces the amount of gas going into the burner, and so now you have just a small flame coming out the top. When there's more demand, of course, then the fan speeds up and you get a higher flame. Now here is the heat exchanger. So here you have the hot and cold lines going to this thing, and they sort of wrap around this copper box. They kind of make a couple of wraparounds, and then what you have inside is this thinned copper. So you see in the ends,
thinned copper.
Yeah, it's thinned copper. And so you have the water flowing through all these tubes. This thinned copper is not unlike many copper boilers that I've seen. And so the flames are going up through those copper fins.
Look at that.
Yeah? What's that? Burner. The burner. And so then the flame comes out the top. Here's top view. Comes through those copper.
That's the window.
Fins. Yeah, that window is where the igniter went. The igniter and the flame rod. They bolt to the front of this
thing here.
Yeah, to the front of the burner. I forget how it came apart, but anyway, it goes on the front of that.
The front there.
Yeah. So then, out the top of this copper heat exchanger is this top where it collects the flue gases and the exhaust out through here. The fresh air is brought in around the outside, and that's what came in.
It goes up here.
Around the side through this thing.
It's going on here.
So anyway, that's the guts of this Rinnai heat exchanger, tankless water heater.
Tankless water heater.
And I suspect most tankless water heaters are very similar. They have a burner design which can ignite and start to heat the water at almost
This is all going to
almost as fast
water
as
heater.
you can turn the water on. You know, there's a slight delay between the time you turn the water on and that it actually ignites the flame. So you have some hesitation there when you first turn on your water. And then as the water flows, the sensors take over, the sensors on the piping, which will tell you the inlet temperature and outlet temperature of the water, and it can determine the speed of the fan, which then determines the amount of gas going into the burner, which then heats the water at the proper rate. So in other words, you don't want to fire this at 200,000 BTUs when you have a gallon per minute flow through it. You need, you know, these, you know, at say 50 degree incoming temperature, and if you're expecting say 110, 120 degree water outlet, it's going to be full fired. But when you only have 1 gallon per minute flow, for instance, well, it takes a lot less gas. It's going to reduce the flame and try and find that equilibrium between the amount of gas it's putting in and the amount of flow of water you have going through it. So, alrighty. So, a lot of work for a couple dollars worth of copper scrap. Okay, thank you very much. Bye.